Hi, I want to take just a brief moment to talk about the comparison between solids, liquids, and gases. So I have this little table here. We're going to compare solid, liquid, and gas, just some properties of them. Let's talk about the shape of these three. So a solid has a fixed shape. For example, I have a glass of water here, and the glass itself is fixed. It's this conical structure. Now a liquid is going to fill the container. So you can see I have water in here. The shape of the water is the same shape as the container. If I poured the water into a different container, the water would take the shape of that container. That is also true of gases. Gases will fill a container, and so gases fill the container. They take the shape of the container. Fluidity, for all intent and purpose, we say that solids do not flow. Now there are going to be a couple of exceptions when you add a huge amount of time. You can go to old houses and look at the glass. If you look at the thin part of the glass, so if I could look sideways at the glass, it's thin at the top, and at the bottom there's a little bulge because that glass flowed. Glaciers can actually flow, not just physically even move down the mountain, but the solid itself can flow. But you're looking over lots and lots of time, hundreds of years. Liquids, of course, they have high fluidity. If I were to pour, you can even see the water now moving out of that. The water has a high fluidity. Interesting, so do gases. That's the reason why airplanes can fly in the air, is because gas flows. Boats move through the water because of the fluidity of the liquid, and airplanes fly in the air because of the fluidity of gases. Kind of cool that those gases can flow. Now compressibility, this is removing empty space. So again, for all intent and purpose, we say that solids are not compressible. Now you might come up with an example of like a sponge, that the sponge, you can actually remove the empty space, but you're looking at the molecules themselves attached. You can't move empty space between the molecules. Liquids, again, we'll say for all intent and purpose, they're not compressible. Gases, on the other hand, are highly compressible. You have vast amounts of empty space in between gas molecules. If we remove that empty space and force the gas molecules closer, we compress them, and that's how we get compressed gas, how we'll put like propane gas into those white containers. And then density, of course, solids, those are going to have the highest density. That's going to be the most mass per unit volume. Liquids have a high density, not as high as a solid, but they still have a high density. And gases, of course, have a really low density. So there's a quick overview comparing solids, liquids, and gases. Have a nice day. Thank you.